first thing I have on this review sheet is a list of all the derivatives you have to know. So let's see how many of them you can do right now. What's the derivative of x to the n?
nx minus nx to the n minus 1.
Yep. Okay, how about e to the x?
E to the x.
Sine's derivative is
For
cosine. Yep. Cosine's derivative is, which other trig functions have negative derivatives?
all cofunctions.
So cosecant and cotangent. Okay. How about tangent's derivative?
Secant squared.
Mm-hmm. Secant's derivative? Mm-hmm. Okay, cosecant's derivative is kind of like secant's derivative. Uh-huh. X and cotangent x. Yeah, I almost wrote tangent, which was wrong. Okay. Cotangent's derivative. Mm-hmm. Okay, how about ln's derivative? 1 over x, yep. Okay, a to the x.
I got scared of that one.
You got scared in that one. ln a times a to the x. Kind of similar to this guy, right?
Yeah.
Okay, and that was the point there. They're quite similar. The first one has, the second one just has the ln a in there. And actually, you could do e to the x that way too, because ln of v is 1. Which derivative do you think log a is kind of similar to? The ln one, because ln's also a logarithm, right? So this is going to be 1 over ln a times whatever is in the x. Okay, arc sine? Yep. Arc cosine?
Same thing
Same thing
but negative.
but negative. And arctan?
1 plus x squared.
1 over 1 plus x. Okay, so the ones you probably need to work on are this one and this one, right? The rest of them are more or less okay. So it's not even that bad. Look, 2 out of a list of a gazillion. Okay. So there's your list. I would suggest writing instead of staring. Works better. Yes?
And for the log, do you multiply the derivative of x?
You do, yes. And the other thing is that whatever, if this x is like a cosine or whatever, that would be what goes in for the x's spot. So yeah, the chain rule applies to all of them if the thing inside of the function is something that's not just plain old x.
Does a have to be, on the third one down on the right, does a have to be a variable? What if it's a number?
A is a number.
It is a
So in both of these, a is a constant.
Okay.
And I guess this is one thing that you could add to the list because it's something you're going to have to know. If you have something like, I don't know, a function to another function, you see variables in both places, remember that? So for example, like y equaled x to the x, for example, okay? Then you have to use log differentiation. That's where you log both sides so you can pull the power down. We'll do an example of that, but yeah, there's no rule if there's a variable in both the base and the power. So the rule that you pointed out, Jimmy, is when the base is a constant. Which one is the rule where the variable is a constant? Which one of those rules has the variable is stupid, the power being a constant, sorry. Bad question.
If your power's a constant?
Power's a constant, first one.
Oh.
Power's a constant, first one. Base is a constant. The start one, first start one.
What?
The base is a constant and the first one that has a star on it,
Oh.
as in this one. Okay. All right, what about constants? Do you have to use the product rule? If you've got a constant times a function? No, you just do constant times function's derivative. You can prove to yourself that you don't need to do that using the product rule, as in this is okay using the product rule. So, but does constants pull out? How about with additions and subtractions? Anything funky there? Nope, that's just f prime plus or minus g prime. How about products? Anything funky there? Well, it's just the product. But the product rule itself is a bit funky, isn't it? Yes, that's going to be f prime of x, g of x, plus f of x g prime of x. Okay, how about the quotient?
I still do the low D high thing.
Me too. I've been doing it for years. So low d high minus high d low all over low squared. Okay, and how about the last one? What rule is that? Chain. F prime of g times g prime x. Okay. And the trickiest thing is recognizing when to use them because they look different with different functions. All right, then just tons of examples. Oh man. Okay, so first I'd write those powers as just like, you know, instead of roots and radicals, what would root of x to the 7th be?
Maybe 2 seconds.
Say that again?
2 seconds.
I think it'd be 7 halves. Okay.
Scary part.
Minus x to the negative 5 halves plus e to the 9th plus 2 pi cubed. And you could just say equals and not say y, but make sure that when you take the derivative you say y prime. So y prime is 7 halves x to the,
Minus 2 2.
so 7 halves minus 2 2s is 5 halves, yep. So 7 halves x to the 5 halves minus negative 5 halves x to the, what's minus 5 halves minus 2 2s. Mm-hmm. Okay, and then what's the derivative of e to the 9th? 0. What's the derivative of 2 pi cubed? 0. Don't let me trick you with those tricky constants. So 7x to the 5 halves over 2 plus 5 over 2x to the 7 halves. And I'm probably going to ask you to get a common denominator sometime, so let's just do it in every problem that I think it's a good idea right now. So what would you multiply the first ratio by to get a common denominator? X to the 7 2s. And then what happens to those exponents? They add. So 7, and that's going to be 12 halves, right? Which is 6. Plus 5 over 2x to the 7 halves. When I want you to do that, I'll put like a disclaimer on the front of the test. I'm going to use the word simplify because it gets like to be too much to like write down what I mean by simplify. It means get a common denom, take out greatest common factors. Those two things is what it really means when I say simplify. And I'll state that in the front of the test so you know as well, but like I'm just going to say that in the directions. And that's what, if I don't say that, you don't have to do it. Okay, this guy. Now you can use the quotient rule. I think that would be a bad idea. It's better to write this as x to the 4th over root x minus 2x over root x plus 1 over root x. And then use your exponent rules to simplify, and then you can just use the power rule. So what's 4 minus a half? So 4 is 8 halves minus 1 half is, I think it's 7 halves, right? Because 4 is equal to 8 over 2. Minus 2x to the, what's the power going to be on that one? 1 half. And how about the last one? The power on that x will be negative 1 half. Yep. Okay, y prime equals. All right, so 7/2 x to the new power of 5/2 minus 2 times a half x to the new power of negative a half, and then minus a half x to the power of negative 3/2, right? Okay.
Would have got it really messy if you just brought the root x out.
And did the product rule? It would have been uglier. Yep. It would, yeah, it would have been not maybe as bad as the quotient rule, but it would have not been that pretty either. This really is the best way. Okay. So let's get a common denominator. Multiply x to 3/2 there. This one, obviously 2/2, right? What could you multiply x to the 1/2 by to make it x to the 3/2? So 1/2 plus what is going to give you 2/2, so which is just x over x. Right, because when those exponents add, you get 1/2 plus 1 is 3/2. And the last one just stays. So your derivative is 7x to the, that's going to be a nice whole number power. What is it? 4. Great. Minus 2x minus 1 all over 2x to the 3/2. There you go.
Seems weird when it goes back to the same. You start with x to the 4th. Not with x to the 4th again.
Yeah, just there's things that, yeah, stuff like that happens. Yeah. Okay. How about this guy? What rule are you going to have to use, and on which part?
The product rule?
The product rule. Yeah, there's no change. There's nothing inside of anything else. So, what's the derivative of the 2x part? 2. Okay, and then with this x squared tan x squared is like our first function, tan x is like our second function, right? So you have minus 2x tan x plus x squared times. Now there's one thing I did wrong there. You need to have parentheses around this. Because when you do the product rule, it's coming from something that is all subtracted. You could also think about the negative as being part of the x squared and just carry the negative along the second term. So that derivative is 2 minus 2x tan x plus minus, x squared secant squared x. And I don't think that can simplify at all. I don't think anything factors out.
Yes, secant is 1 over cosine, that doesn't.
You could maybe change the secants into tangents somehow and maybe simplify that different, like maybe, but no, that's good enough. I'm just checking that you can take care of the negative correctly. That's kind of the important thing on that one. How about this one? What rule are you going to use? Or quotient. Do you want to use product though, just cause?
Yeah.
Yeah? Sure, why not? Okay, but then I can't sing the song. Oh. Okay, sine of 2x times x to the negative second. Okay, so y prime is, sine's derivative is cosine. Because I differentiated the sine of 2x, what do I have to multiply by? 2, because of the chain rule, good. Plus sine of 2x multiplied by the derivative of x to the negative second, which is, yep. Okay, so that's 2 cosine of 2x over x squared minus 2 sine of 2x over x cubed. Is that okay with everybody? Just put the negative exponents in denominators. Now, is it hard to get a common denominator in this thing? What do? In the first term, x over x. And is there, at the same stage, is there a greatest common factor that could be factored out? I think just 2, because there's no x in the second term. So 2x cosine of 2x minus sine of 2x, all that's going to be over x to the third. The quotient rule will give you the same thing. It might be a tad bit easier to simplify a little bit by factoring out and canceling, I think. Okay. Whoa, log base 5. All right, so f prime of x. What rule is this? It's the log base a rule. So if I give you y equals log base a of x, what was the derivative? So this will be 1 over ln of 5. And what goes in for the x? 3x to the 5th plus 1 times the derivative of 3x to the 5th plus 1, which is, and I also forgot one thing. I forgot there's 3 right there, but it just stays in the front, right? Because as a constant, it just factors out. I just missed it by accident. So, and the only simplifying you can do is multiplying that 3 and that 15, which gives you f prime of x is 45x to the 4th over ln 5 times 3x to the 5th plus 1. Is that okay? All right. I mean, if you don't know this formula, you're in a bit of trouble, right?
Yeah.
So this one's crazy. Okay. So the first thing is that this squared business, that's the same thing as cosine of 3x to the second power, right? Okay. So y prime is, what's 1's derivative? What's 1's derivative? 0. Okay. What's the derivative of cosine? So negative sine, the x over 2 stays inside, times the derivative of x over 2. Do you have to use the quotient rule on that? Oh God, no. It's just 1/2 x, right? Because you're tight. What's the derivative of 1/2 x? 1/2. Okay, plus 2 times. Now on this piece, which part gets chained first? This, the outer function, which is the squared or the cosine? The squared. So the 2 comes down. The new power on that stuff is 1. Then you multiply by the derivative of cosine, which is, and then technically there's one more chain. Derivative of 3x is 3. So you've got 1/2 sine x over 2 minus, what's that, 12? Cosine of 3x sine of 3x. Is that okay? All right. How about you try this next one? It's kind of similar, right? It's actually even an easier chain rule. Other than you must know secant's derivative.
So secant.
That's right.
Could you get rid of the fractions?
you could write them as, excuse me, 1/7 secant of x to the 7th minus a 5th secant of x. Is that what you mean? Like that? Yeah, totally. Yeah, that's something you can do with them. Okay. So then what's the first thing that happens with that power on the secant? And it does what to that 1/7? Yay! Secant x to the 6th times, what's the derivative of secant? Yep, secant x tan x. And then minus a 5th times 5 secant of x to the 4th, right? Times, once again, secant x tan x, right? So goodness, I think that's secant to the 7th x times tan x plus secant to the 5th x times tan x. Do you guys agree? Because you've got secant to the 6th times another secant, right? That makes secant to the 7th.
I just factored secant x tangent x out of there and got secant x tangent x times secant 6 of x.
Okay.
minus secant 4th
So you had
x.
secant x tan x, factored out because that's a sure. Then you've got secant to the 6th x minus secant to the 4th x, right?
Yeah.
Is there any more greatest common factor that can come out at that stage? Secant to the 4th. So that's going to make this secant to the 5th x tan x times secant squared x minus 1. I mean, you could have got, and I made a mistake there. This should have been a minus, not a plus. Is that what you were going to ask, Natalie? Yep. Okay, so I'd take that totally as good enough. But this was a textbook question. They may have changed secant squared x minus 1 into something. Because isn't that tangent squared x? Because isn't it says tangent squared x plus 1 equals secant squared x, right? So secant squared minus 1 is the same thing as tan squared. I wouldn't necessarily make, it's really hard to legislate, like, in directions to do that. But it's just good to know that that's, you know, that could happen. When you take, if you take calculus 2, you're going to have to do a lot of stuff where you use these identities to reverse this differentiation process. So it's good to be a little bit familiar with them just in case you got to take that class.
What do you want us to factor out?
You know, like I said, you have to take out what I put in a box, right? That you have to go at least this far. Yes, you must take out greatest common factors. Do you have to recognize that that's tangent squared x? No. So, like I just said, it's something that's good to point out, but you don't have to do it. Okay. Oh man, what rule is this one? In which orders? Chain? Is that your same? Part B? Or is your part B different?
No, it's the same.
It's the same. Mary Kate gave it a look like it was different or something.
I was on the other page.
Okay, yeah, that's,
What are we doing?
yeah, so what rule do you do chain and then what? Okay, so f prime of x, the first thing you differentiate, first of all, the 3 doesn't matter, just leave it alone, right? You have e to the stuff. What's the derivative of e to the stuff? E to the stuff. The stuff does not change. Times stuff derivative, which you could use d over dx or prime. So 3 e to the x cotangent x. Okay. Now don't go making up a product rule now because you don't know it's not f prime g prime. What is the derivative of x cotangent x? Okay, plus x times, I think, negative cosecant squared x. Do you guys agree? First you differentiate the x, derivative is 1, right? And then plus x times negative cosecant squared x. So that's just 3 e to the x cotangent of x times cotangent x minus x cosecant squared x. And there's really no easy greatest common factors there, so that's good enough. Are the parentheses important? Yes, because you have to have the e to the x cotangent x multiplied by the entire expression. Okay. Find an equation of a tangent line to this function at that point. So if you're asked to get an equation of a tangent line, do you have to simplify your derivative? We don't really have to, right? So I think also this one probably is easier to use the quotient rule. Okay, so we got low d high. What's the derivative of the upper function?
Negative sin x.
Minus high d low.
Sine of x.
All over low squared. I'm just not going to simplify. I'm just going to plug in pi halves. Saves you time, doesn't it? Oops, I don't know why I did that. Okay, minus 1 plus cosine pi halves, sine pi halves. And of course, if you can plug in pi halves in your heads, I'm not gonna fault you. And you should really be able to. So what are the coordinates at pi halves? What? Or is that your answer? Okay, you skipped steps. So the coordinates at pi halves are x is 0, y is 1, right? Yes? Yeah, like the coordinates are -3, what? Okay. All right, so your m is, it's going to be 1 minus, what's the cosine?
0.
Times -1. Minus 1 plus 0 times 1. All over 1 minus 0 squared. I think the slope is -2. You guys agree with that? Okay. I don't know how you got -3. No. Happens. All right, then what's the equation of the line? Y minus y1 equals mx minus x1. Okay, what goes in for y1? What goes in for m? And then x minus pi over 2. Or if you felt like getting it into slope-intercept form, you could say y equals -2x. It'd be plus pi plus 1, right? Definitely plus pi. Because the negative distributes. Is that okay? All right. And then the next question is like the product quotient rule problem that gave you guys so much trouble that one day. Remember that problem? Where there were all sorts of sillies made? No, you don't remember this problem? It was in 3-4 part 2. There was a problem that I said, do this one using the quotient rule and then the product rule and simplify your answers, and they're going to give the same thing. This is just like that. I think the product rule is simpler here. So write this as 3x times x squared plus 1 to the power of Okay, and then what rules are you going to use to take the derivative of this? It's product first and then chain. Does that make sense? Like the chain comes up in the course of doing the product rule. Okay, so if you're going to do the product rule, what's the derivative of 3x?
3.
Yay. Okay, plus 3x times x squared plus 1 to the Mm-hmm.
Jinx, you owe me a soda.
Times. Except for soda's bad for you. Okay. Express the first term as a ratio. Something over something else. Sure. Express the second thing as a ratio. Who's in the numerator? Do you guys agree with 3x? Okay, so let's think for a second because I made a boo-boo I need to erase. So first of all, positive or negative? Negative. Okay, second of all, does anything cancel? Really? The 2's do, don't they? This 1/2 and that 2 cancel. Yes? Okay, so the number is a 3. What power is on the x? Squared. Okay, and what's in the denominator? Mm-hmm. Okay, good. Now, to get a common denominator, how are you going to make the first denominator into a power of 3/2? By x squared plus 1 to the first. That's what you meant, right? Okay. So that's 3x squared plus 3 minus 3x squared over x squared plus 1 to the 3/2, or 3 over x squared plus 1 to the 3/2. Does the common denominator thing make sense? It's the exact same thing we had when we had, wasn't there a different question earlier on where we had something like 1 over root x and then like minus 1 over x to the 3/2? It's the same process, right? It's just that the thing, instead of being an x, is an x squared plus 1. Okay, so when you see a logarithm, so if you see log, big question, that's the big Q, can you expand? And if you can, do it before taking the derivative. So with this one, can you expand? No, because it would need to be x to the 7th, not ln x to the 7th. Does that make sense? So g prime of x in this case will be 7 ln x to the new power of 6 times 1 over x. Or g prime of x is 7 ln x to the 6th over x. Versus this function. Okay? With that function, what would be the smart way to take its derivative? Bring the 7 down, and that's still the original function. And then the derivative is going to be just 7 over x, right? If you didn't see that, you'd have g prime of x is 1 over x to the 7th times 7x to the 6th, which is the same thing as that, right? It's just that when the things inside of your logs get significantly more complicated, in this problem, not recognizing you can expand is not a problem. But in part B, it could be more of a problem. If you didn't see that you could expand this, you'd have to use the chain rule and the product rule and the chain rule again. Or you can be like, oh, log of a product. That's the same thing as log first thing plus log second thing, right? Yes, and then what else can you do? Pull the 2/3 down. is this logarithmic differentiation? So logarithmic differentiation. This is when you log both sides. And by log, I mean ln. Did we log both sides in this one? The log was already there. Does that make sense? So it's not logarithmic differentiation, but it does share some properties. Okay, now are the derivative, is the derivative going to be very hard? ln x's derivative is plus 2/3 times 1 over x plus 4x squared over 3x squared minus 2. I'm probably going to ask you to simplify this as well because it's not super difficult. As in, can you get a common denominator here? Is the 4x squared? Say that again? Oh, it should be 4x, not 4x squared. I'm so sorry. Yep. I was just testing you. So that should have been 4x. Yep. Okay. So what would you multiply by to make the denominators common? First one needs a 3 and an x squared minus 2, right? What does the second one need? An x over x. So that'll be 3x squared minus 6 plus 4x squared over 3x x squared minus 2, or 7x squared minus 6 over gazoon, like gazoon type, coffite, whatever, 3x squared. 3x times x squared minus 2. Okay. Is how I got the numerator okay? All right. So the point is, if you see a log, ask yourself, can I expand it before I do derivatives? And if the answer is yes, do it. If the answer is no, just take the derivative. Okay, but usually the expansion will make it a lot easier. God, I can't remember what quiz it was on, but the quiz that covered section 3.6. Like that quiz had a question like that on it, and it was a lot easier if you did the expansion. Okay, 10 to the stuff. What differentiation formula do we use for this guy? It's the formula for the derivative of a to the x. Does that make sense? Okay, and the derivative of that guy is ln a times a to the x, right?
And there's a chain rule there.
Yep, and I made a bit of a boo-boo. They should both be the same variable, so let's just change this t to an x. And there's also a chain rule there, twice actually, right? Okay, h prime of x. So
Can I just keep a t and say this equals 0?
no. Okay, so first of all, what's the derivative of 10 to the stuff? Ln 10 times 10 to the stuff, okay? Then you've got to multiply by derivative of stuff. So who's the next part you differentiate? So that'd be negative sine, and what's inside your sine? Pi x. And then times, one more thing. What's the derivative of pi x? Pi. Okay, great. So negative pi ln 10 times 10 to the cosine pi x sine pi x. There's no rule that say constants have to go out in front, but they're often out in front. So
Does it matter what order my final answer's in?
nope, because multiplication is commutative, so the order in which you multiply doesn't matter. It's just usually the case that constants are written first, but it doesn't matter. You could leave it in whatever order. It's just nice to put the negative in front, because otherwise it looks kind of like a fraction. But if you didn't, I couldn't dock you, because really it is the same thing. Is that all right?
Yeah, just one big ugly product.
Yeah, it's one big ugly thing. Yep. I don't wanna. We're not gonna do it. Okay, find the second derivative of the following functions. Which means first you gotta get the first derivative, right? Like to find the second derivative, you must get the first. So what is the first derivative of secant of 5x?
Did we get the,
Did that change a question on you?
well,
We didn't get the second.
we didn't get the second derivative of that big nasty thing.
For A.
Well, we just did, we just did the first one,
Agreed.
It's you gotta use the product rule on it. It's just gonna be gross. No, we're just gonna skip that part. We're gonna do the second derivative in this one, because it's not quite so bad.
We do that on the exam.
No argument.
Well, on the exam, I vet the problems a lot more carefully than I do on my notes. So no, because I've checked them much, much more thoroughly. So secant of 5x. So what's secant of 5x's derivative? Secant 5x tan 5x times 5. Okay, so 5. On this one, I do actually want to find a second derivative. Okay, what rule do you have to use to get the second derivative? The product rule. The 5 can just sort of chill, right? Okay, I'm going to do a big old set of parentheses. First, differentiate the secant. So secant 5x tan 5x times another 5, right? And then times the tangent 5x that was the second function. So that's the, that's sort of the first thing. And then plus what comes next? The secant 5x gets left alone, multiplied by the derivative of tangent of 5x, and that's going to be, someone said it's secant squared, and then times 5. Okay. Before we take out any GCFs, let's just sort of simplify those expressions. So I have 5, this first one, how could you write that more nicely? Secant 5x, tan squared 5x. Okay, how about the second one? 5 times. Great. And is there any greatest common factor that you can take out? Secant 5x and 5. So that will be 25 secant 5x times tan squared of 5x plus secant squared of 5x. And that second bit doesn't obviously simplify. Okay. Is that all right? Oh, man. Implicit differentiation, right? Okay, and you have to use the product rule on everybody, right? Okay, so first, y e to the x. So what's the derivative of y?
Y prime.
Y prime, e to the x, plus,
X prime.
when x prime is just going to be 1. We don't do x prime, we just do dy dx. Okay, how about the next bit? How about differentiating x e to the y? So 1 e to the y, sure. On that one? No. Okay, but the next term is going to be what? What happens to the x?
Just the same.
Stay the same. Okay, e to the y, and that one needs to be times. That one needs a y prime. on the first one? Y is your first function, e to the x is your second function. So first I differentiate y, right? Is that okay? All right. Now how about x times y? What's the derivative of x times y going to be? How do you product rule? Okay, so first derivative is, x's derivative is 1. Does anything happen to the y? No. Plus, next what do you do? Leave x alone and then multiply by y's derivative, which is y prime or dy dx. You know, who cares, right? Same thing. Don't forget how to product rule with stuff like this. Like, you know the product rule, differentiate the first function, not the second. Leave the first alone, differentiate the second. Just do one at a time. Okay, let's get all the y primes on the left side. So you've got y prime e to the x. Who else stays over there? X e to the y, y prime. And then who else is over there? And it's positive or negative? Okay. On the other side, you have y minus y e to the x. There you go. You could look from step 1 to step 2 and see if you actually have all things. There are 6 terms, right? Do you see what I mean by that? And then there are 6 in the next step as well, so you can know that you've probably kept track of all of them if you look at that. And now what? The next thing you take out the y prime, e to the x plus x e to the y minus x equals y minus y e to the x minus e to the y. Holy shiznits. Okay, so what's y prime equal to?
The left side. We just write y prime equals right side over the left side.
No, but you could jump from this step to this step right away if you felt like it.
Yeah.
Does that, you see what I'm saying? Like, if you want to do the factor out and divide in the same step, I don't care, because like it is totally obvious, I think, what you're going to get when you're at the first step where that arrow starts, right?
Yeah.
So, I mean, that will save you some writing, and you're welcome to do so. But you can't do left over right. Or right over left, whatever you want to say. Because technically, though, if you had said right over left, that would include like the y prime of the left side as well.
I guess the left minus y prime.
Yeah, I know what you mean, but you see what I'm saying? Like, you can skip some steps in that way, but you can't do what you're asking. Okay, cosine of x plus y equals x. Okay, so first you differentiate the cosine. Negative sign. Okay, x plus y. And you multiply by the derivative of x plus y. So what's that going to be? 1 plus y prime. Do you guys buy that? Okay, and it's going to equal 1. You can do one of two things. You can divide by negative sign, or you can distribute. Sure. Can I do it both ways, just to show you what's going to look, how it's going to look different? So if you divide by negative sign, you're going to get 1 plus y prime equals 1 over negative sign of x plus y. How could you express that differently? 1 over negative sign is the same thing as 1 over sign is cosecant. So you could say negative 1 minus cosecant x plus y. Does that make sense? Okay, so that's one way. If you distribute, you get negative sign x plus y, oh, sorry, not plus, minus sign of x plus y prime equals 1. Is that okay? Then you add the sign of stuff over. And then you divide by the negative sign of x plus y. Is that answer the same thing? It is definitely harder, but the thing is, in some instances, dividing isn't gonna make your answer all that much nicer, so it's also good to know distribution is an option. Does that make sense? Like, if you had y primes inside of parentheses on both sides, for example, but they're equivalent, you can give me either answer. Okay, is that all right?
Yeah, those answers are way different.
They do, but the reason they're the same is you could make this into positive 1 over negative sine of x plus y plus sine of x plus y. You could sort of unadd the common denominator, like that. And then the 1 over negative sine x plus y, that's the negative cosecant thing, right? And then sine x plus y over sine x plus y is the negative 1. So they are the same thing. Okay. This one specifically says use logarithmic differentiation to find dy dx. So when the directions say that, what does that mean? What do you do to both sides? Ln both sides. In these cases, you won't have to simplify. So ln of y equals ln of 2x plus 1 to the third cosine squared x over root x squared plus 3. And in one go, I want you to expand that, having the powers pulled down and made it into like additions and subtractions. Okay. So the first part is ln of what? 2x plus 1, and what's the coefficient in front? 3. Yup. Yup. I must say that the first time I taught natural logs to my Algebra 2 students, I didn't value enough how it's good to be able to do this stuff quickly. So, do you see what I'm saying? Yeah. Okay. Quite quickly. You know that the multiplications are going to make additions, right? The divisions make subtractions. You know that the powers pull down. That's just, those two things. Okay, then take the derivative. What's the derivative of natural log of y? 1 over y dy dx, spectacular, equals 3 times which is 2. Yep, good job. Okay, plus 2 times 1 over cosine x times what from the chain rule on that guy? Negative sine. And then minus a half times 1 over x squared plus 3 times what from the chain rule? 2x. Great. And now I'm going to be slightly lazy and do 2 steps at once. I'm going to multiply the y to the, well, actually I'll do both. I'll write them both down. You can do this in one step if you want. So that first ratio is 6 over 2x plus 1, right? Okay, the second ratio is, you could say negative 2 sine over cosine, or you could say negative 2 tangent. I'm not going to dock you if you don't say tangent, but you could say tangent. And then how about the last one? And where's that y going to go? Just right there, right? Multiplied it over. What's the very, very, very last thing you have to do? No. No common denominator needed. Nope. But you know what y is, don't you? So you plug y in. So this is what you could do this in one step because it saves you a lot of writing to do so, but you do have to plug in what y is. And I'm pretty sure that WebAssign would tell you that you're wrong if you didn't. So I remember a student saying, I did it just like you did in class, and WebAssign said I was wrong, and I'm like, pretty sure that I plugged y in class, and you are wrong. Sorry, it was late and I got my sassy on. Oh, it's gross, yes. But if the purpose of your derivative is to plug in numbers and find rates of change, you can do so, right?
Why does calculus hate us? Why does it want us to be so unhappy?
Calculus is an inanimate object and lacks feelings. Okay,
I can tell.
So it's not that it doesn't want to hurt us, it just doesn't care.
just doesn't care, no. No, and it also lacks the ability to care. On this one, you have to use logarithmic differentiation. There's no other option. So natural log y equals natural log of cosine of x to the x power. So then the x pulls down, and you have x times natural log of cosine of x. And now what rule do you have to use to get the derivative of this guy? On the right side, what rule does that require? The product and chain. And don't go making a bad product rule, use the real one. So we've got ln y's derivative is 1 over y, dy dx. When you're differentiating x ln of cosine x, first you differentiate x, right? His derivative is 1. I don't know why x is a guy. X ln cosine x plus x times, what's the derivative of ln of cosine x? 1 over sine times negative crap. Not times negative crap, that's not actually the derivative. 1 over cosine times negative sine. So you have dy dx is equal to natural log of cosine x minus, I'm just going to say x tangent x times y. And final step is to what? Plug in y. So dy dx is natural log of cosine x minus x tan x times cosine of x to the x power. So on that one, you actually have to use the log diff thing or it won't work. There's no other way. Okay. And then a couple that use arc sine, arc cosine, and all that fun stuff. So what's the derivative of arc sine?
1 over 1 minus x.
Okay, so first we'll have 1 over the root, 1 minus what goes in for the e to the 3x, and that is squared, times the derivative of e to the 3x. So what's the derivative of e to the 3x going to be? E to the 3x times 3, right? Okay, so f prime of x, the 3e to the 3x is in the numerator. Now, what happens to those exponents in the denominator? Don't answer yet, okay? Don't tell me. If you had x squared to the 5th, think about it for a second and tell me what happens to the exponents. They multiply. When do exponents add? What would you have to have had?
X squared prime.
Okay, so what happens to those exponents? Is it more like this one or more like that one? Top one, so what happens to them? They multiply, that becomes 6x. Or you could think e to the 3x squared means e to the 3x times e to the 3x, and then they add, right? 3x plus 3x is 6x, right? I mean, so either way. Okay, how about arctan of 5x to the 5th. Mm-hmm. That whole thing squared, right? Multiplied by the derivative of 5x to the 5th, which is 5 times 25x to the 4th, yep. So your numerator is 25x to the 4th. What's your denominator going to be? 1 plus? The x to the 10th is correct. 25. Can those 25s cancel? No, don't kill any kittens, okay? Killing kittens is bad. All right. How about this one? What rules is this one going to use? Not quotient rule though, right? Okay, give it a try, okay? Start. Just give it a go. This part uses the product rule. Don't forget the arctan 2x uses the chain, right? This part uses the chain rule only, but try to take the derivative. It's going to simplify a lot, is my hint, okay? So just attempt. Anybody get it? Anybody dare say what their answer was? It should be arctan of 2x. So I'll run through it, okay? So first you differentiate x, right? X's derivative is 1. So you've got 1 arctan of 2x, right? The next term you leave the x alone, right? Multiply by 1 over 1 plus 2x squared, right? Because the 2x has to go in for that spot, times the, what, from the 2 from the chain rule. Does that make sense? Okay, minus, next part, a quarter. What's the derivative of ln of that stuff? It'll be 1 over stuff. And then what's the derivative of the stuff? Okay. So you've got arc tan 2x plus 2x over, that really is 4x squared, right? And then what does the 8 over 4 reduce to? 2x over, yes. And then the 2x over stuff minus 2x over same stuff means goodbye. And your derivative is just arctan 2x, right? All right. That's it for number 1, right? Part 1, yeah. Okay, so we're going to pause.